Simultaneous equations. So in order to use the elimination method to solve our simultaneous equations, we need to meet certain criteria first. The coefficients of one of the two variables must be the same, and this may require scaling, so making equivalent equations by multiplying or dividing both equations or one of the equations by a particular number. If the signs of that variable are different, so in other words, one of the variables is positive and the other one is negative, then we add one equation to the other to eliminate that variable so that we can solve for the other. If the signs of that variable are the same, then we're going to subtract one equation from the other to eliminate that variable. And once we've solved for the variable that's left, we can substitute to solve for both variables. So in example 1, we're going to solve x plus y equals 59 and x take away y equals 31. So the first thing we're going to do is we're going to label the equations. So x plus y equals 59, we're going to label equation 1. And x take away y equals 31, we're going to label equation 2. Next, the coefficients of y are the same. So they have different signs. We've got a positive y in equation 1 and a negative y in equation 2. So we're going to add the equations to eliminate y and solve for x. So if we do equation 1 plus equation 2, we get 2x equals 90. We need to isolate x, so we're going to divide both sides by 2, and that leaves us with x equals 45. The next thing we need to do is we need to substitute that value of x back into 1 and solve for y. So if we take that x equals 45 and replace the x, we get 45 plus y equals 59. Now we need to take away 45 from both sides, applying the inverse process to isolate y, and we get y equals 14. So the final thing we need to do is we need to mentally check the solutions by substituting both values back into both equations. So 45 plus 14 equals 59 means that equation 1 is true, and 45 take away 14 equals 31 means that equation 2 is true, and so our solutions for these linear equations are x equals 45 and y equals 14. So in our second example, we're going to solve 2c take away d equals 5 and 2c plus 3d equals negative 7. So step 1, we're going to label the equations. So 2c take away d equals 5 is going to be equation 1, and 2c plus 3d equals negative 7 is going to be equation 2. Now, we need to look at the variables of c and d, and you can see this time the coefficients of c are the same. They have the same signs, they're both positive, so we're going to subtract the equations to eliminate c and solve for d. So what we need to do is 1 take away 2. That eliminates c, and we end up with negative 4d equals 12, because 5 take away negative 7 is the same as 5 plus 7, which gives us our 12. Now we need to solve for d, so we're going to divide both sides by negative 4, and then we're going to get d equals negative 3. The next thing we need to do is substitute this value of d back into equation 1 and solve for c. So equation 1 was 2c take away d equals 5. So we're going to replace the d with the negative 3. So 2c take away negative 3 equals 5. And we know that that means it's 2c plus 3. So if we take away 3 from both sides, we're going to get 2c equals 2. We're going to divide both sides by 2, and that gives us c equals 1. Next thing we need to do is mentally check the solutions by substituting both values back into both equations. and 2 take away negative 3 equals 5, so equation 1 is true, and 2 plus 3 times negative 3, which is negative 9, is indeed negative 7, so equation 2 is true. So our unique solution for this pair of linear equations is C equals 1 and D equals negative 3.